Welcome back to our YouTube channel. Today we will talk about the equations of motion. In our previous video from our physics series, we discussed some quantities, which we'll be using to derive the equations. So, if you haven't watched that video yet, you can find the link in description. So without further ado, let's start. For the first equation of motion, consider a body which is moving with an initial velocity of vi. After an interval of time t, the velocity of the body changes to vf, or the final velocity of the body. For the change in velocity, we will subtract initial velocity, vi, from the final velocity, vf. Rate means change with respect to time. So, the rate of change in velocity means dividing time, t, by vf minus vi. But by definition, rate of change in velocity is acceleration. Therefore, a equals to vf minus vi upon t. T is dividing on the right-hand side, so we will send it to the left, where it will then multiply to a. Since vi is subtracting on the right side, we will send it towards left, where it will add to a t. Now, the equation becomes vf equals to vi plus a t, which is the required first equation of motion. For the second equation of motion, consider a body which is moving and changes its position and covers a distance, s, in time, t, in a particular direction. Also, if the total displacement, s, is divided by the time t, we get the average velocity. v equals to s upon t. We will send the dividing t from the right side to the left. The equation becomes s equals to vt. Suppose it's our equation 1. Also, the average velocity, v, equals to vf plus vi upon 2. Suppose it's our equation 2. Now substitute equation 2 in 1, that is, place the value of v in equation 1. Then the equation becomes s equals to vf plus vi upon 2 multiplied by t, which is our equation 3. Using first equation of motion, vf equals to vi plus a t, which becomes our equation number 4. Now put equation 4 in equation 3. That is, the equation becomes s equals to vi plus a t plus vi upon 2 multiplied by t. Add both vi. The equation becomes s equals to 2vi plus a t upon 2 multiplied by t. Now break the LCM, and then the equation becomes s equals to 2vi upon 2 plus half a t multiplied by t. The 2 will be cancelled since there is one multiplying and other one is dividing. In the end, the equation will be multiplied by t, and the equation will become s equals to vit plus half a t squared, which is our required second equation of motion. Consider the same body for third equation of motion, and we will repeat the same steps till equation 3 as we did in second equation of motion. After that, we know a equals to vf minus vi upon t. We will cross multiply a and t, which will then become our equation number 4. Put equation 4 in equation 3, that is, s equals to vf plus vi upon 2 multiplied by vf minus vi upon a. Then use the mathematical formula a plus b into a minus b equals to a square minus b square. S equals to vf square minus vi square upon 2a. Since 2a is dividing on the right-hand side, we will send it to the left, where it will then multiply to s. The final equation becomes 2as equals to vf square minus vi square. This is the required third equation of motion. Thank you for watching. Hope you enjoyed and learned from the video. Your feedback is highly appreciated in the comments section below. Be sure to give the video a thumbs up and do subscribe to our channel.